if the absolute value of the series converges. Then the original series also converges. This condition is...
Is that a rule or is that just describing?
It's just describing whether it's going to converge absolutely or not. So to figure out whether it's going to converge absolutely or conditionally, we will first see if the absolute value of the series converges. Does it make sense? We take the absolute value of it.
Take the absolute
Value of the series. We will do problems and you will understand what I mean by that.
okay.
When the absolute value of the series converge, then the original series converges. Okay, so no doubt about it. If this is true, this is automatically true. So then we call the OG series converging absolutely. Okay, but if the absolute value series diverges, so the absolute value of the series diverge, then there are two possibilities. Depending on whether the OG series converge or diverge, we say, so the OG also, OG converge, OG diverge. If the absolute value diverges and the original series converges, then it is converging conditionally. But if both of them diverges, it is a divergent series. Okay, so we're going to use all the tests there is that we have known and use those tests to figure out if it is going to converge absolutely, converge conditionally, or diverges. Okay? So the only possibility is when the absolute value, you take absolute value of the series and you find out that absolute value of the series converge, it's an automatic converging, absolutely. You don't even have to check for whether the original series converges, right? Because there is no other possibility. But if the absolute value of the series diverge, that's when you have to check for the original series to see if it converges or diverges, because there are two possibilities. Okay, we'll do examples, you'll be fine. Starting with example 1. This is a given series. What kind of series is this?
It's a ratio.
Oh, no, the...
Oh, it's a geometry.
It's the little, the ones that we were doing. Alternating.
Oh, well, I wasn't here. So,
That was the video.
Okay, so
I didn't have time to
start
watch
with
this.
taking absolute value of that series. When you take absolute value of a number, what are we looking for?
a positive
The
number.
positive. So what would be the positive of the series? You're going to ignore the alternating number.
3 to the n over n factorial.
Sorry, what?
3 to the n over
Yep,
n factorial.
3 to the n over n factorial. Go ahead and... Oh, God.
You cold, miss?
Yeah.
Miss, where did you get that hoodie?
Huh?
Where did you get that hoodie?
This is only for teachers.
Could you get me one?
No, you have the t-shirt.
Yeah, but I want the hoodie.
I don't think we have any hoodie left. I don't know. I think we gave it away last year.
Oh, wow.
Oh, we did, yeah. Oh no, we only had that hoodie for teachers. Okay, so absolute value of this would be 3 to the n over n factorial, right? We're gonna take the absolute value. This is the absolute value of the given series. Okay. What test can we do to figure out whether this converges or diverges? We're gonna look for the ratio test. When you have like a factorial, when you see a factorial, ratio test is the test to go. Okay, so let's do the ratio test. So I'm using pink for all the absolute value stuff. Limit n approaches infinity, 3 to the n plus 1 over n plus 1 factorial multiplied by n factorial over 3 to the n. And then you separate it, so that will be 3 to the n times 3 times n factorial. In the denominator, I'm going to go just enough so the n factorials cancel out. Cancel, 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 cancel. So what's the limit? Yeah, which would be?
3
Zero.
over n. No.
What?
0.
0. Is 0 less than 1 equal to 1 greater than 1?
Equal to less than 1.
Less than 1, so what happens to this? What happens to this? Converges. We don't need to check for the actual series. Why?
Bless you.
Thank you.
Because when the absolute value converges,
Yep. So we can just say,
that's why we're less confused.
huh?
That's why we're less confused.
Sorry, what? Well, kind of, yeah. Kind of, yes.
God, I'm
The
gonna
rule,
cry.
yes.
Oh,
It's a
no.
theorem. But the
God, don't
the
cry.
other way around doesn't work.
How am I weird?
Oh
Yeah.
no.
Okay,
Because I
Outside.
denied such a delicacy.
so what I'm gonna write here is no need to test OG series, okay? Because if the absolute value converges, there is only one option. What is the option? Converges how?
Absolutely.
Absolutely. That's it. Okay. Shall we move on?
So the absolute value of this would be 1 to the n plus 1 of
The absolute value of this would be
cube root of n. Take the limit. And then infinity.
1 to the n plus 1 or just 1 over cube root of n, right? What series is that?
It's a
P series, good job. So that means P series with a P, what is a P?
1 over 3.
1/3. So is that less than 1, greater than 1? So what happens to a series? If the P is less than or equal to 1, what happens to the P series?
divergence.
Diverges. So this is a divergent series. The absolute value is a divergent series. So that means we have to check for the original series to see if that converges or diverges. When the original converges, then it converges conditionally. If this diverges, both diverges. The original is a what kind of series? Huh? Alternating. It's an alternating P series. What do we know about alternating series test?
They alternate. Oh.
No, before we do the alternating series test, we have to check for two things.
And
decreasing.
the limit is equal to 0.
And the limit is equal to 0. Let's do that. Okay, are you guys, so the pink is all for the absolute value. I'm going to switch my color to white for the original series. It's an alternating series test.
Well, I think, wasn't it for if it's decreasing, then the previous is over the original, and the previous n plus 1 is over the original n?
Or you don't have to, like, or you can just plug in numbers and see what happens. That's fine too. If it is an easy one, for this is easy. I wouldn't worry about, like, messing with things. Okay, let's do the limit first. Because if that fails, then obviously everything fails. So limit n approaches infinity. Ignoring the alternating part, we have 1 over cube root of n. Is that equal to 0?
Negative 1? Or is it the absolute value?
No absolute value of that. Is that equal to 0? The limit is equal to 0. That checks out that condition. And then if I plug in numbers, I will have, so when I plug in 1, this would be a positive. So it will be, I'm just writing the numbers here. So that will be 1 over cube root of 1, right? And then the next sequence in that, or the next term in that series will be negative 1 over cube root of 2. Are you guys with me? And then it will be 1 over cube root of 3, and so on. Again, you don't have to worry about it's only the absolute value anyway, so I'm just going to ignore the negatives. Is it decreasing?
Yes.
Okay. I don't know, you can check with the calculator if you want.
Because the cube root of 1 is just 1.
Yeah.
The cube root of 2 has to be smaller.
Wouldn't it be getting? No.
Just use a calculator.
No, it does. No.
Use a calculator.
Because you're dividing by a decimal.
You're dividing 2 into 3, and 2 into 2 is 1. So 2 into 3 has to be smaller.
Use a calculator. Or graph that. 1 over cube root of n. Okay, now you don't want to use a calculator?
Miss calculators are
Use
for
a calculator now.
For what?
Oh my
Go ahead.
God.
For like
For
Sebastian, also,
we're cavemen. We
You-
don't use calculators.
are not charging your calculator.
I
So
was
my
gone.
trick student is suffering because of that.
I had to charge it too.
no, it's
I had to charge it
increasing.
too, miss. They didn't charge
Miss.
it.
1 over square root of x, right? Do we plug it in like that?
It's not square root, cube root.
I mean
Never
cube
charge
root
for it.
of.
It's getting smaller.
Yeah.
That's what.
or
Okay, your
whatever.
cube root, so it's
So
not
it's
right. You
decreasing.
did 1 over 3
Three.
times square root of x. Don't do that. Make sure you use your math function. Okay, so it's decreasing. You can either plug numbers in, or I don't even know how the graph looks like actually. How does it look like?
It looks crazy. How do I know? It's because I have a calculator in here, guys.
Congratulations.
Thank you. I'm like the next Einstein type shit.
Hold on.
I'm being nice to you,
I know,
Sebastian.
I know. I appreciate it, but no thank you.
Yeah.
What did I do?
Put the X in. Yeah, there we go.
I just like panic.
Can't even
Okay.
politely
So
say no.
it looks like this.
And there's
Kind of
another.
getting closer and closer to 0.
Mhm.
Good. So, okay, well, what does this tell us then?
That is
The original series, what happens to your original series?
convergence.
Converges by the alternating series test. You have to write that here. Or either show me that you did the alternating series test and say converges, or if you don't title it, then tell me that you know that this converges by the alternating series test. Yes, I will be picky and take points off. Okay, so the absolute value diverges and the original converges.
Converges conditionally.
So the entire series, the original series, converges conditionally. Okay, again, number 3.
Sebastian.
So the absolute value is just n over n.
Mm-hmm.
Because all my days.
I know it is cumbersome to keep writing the sigma and all these notations, but I need it done correctly. I can't read your mind. Okay, what's happening here? What test do we use?
Oh my god.
Can we do the nth term test?
Yes.
Okay, when we do the nth term test,
It's 1.
okay. So,
Thank you.
It
That. Yeah, that's
what does the nth term test say?
Wait.
it should not be
the
equal to 0.
It's unmuted.
So it diverges.
Okay, so then let's look at the original series. If you plug in numbers for the original series, what do you think will happen?
Bottom will get larger and larger. The denominator will get larger and larger.
Can you try plugging in numbers? If you take the limit, what would be the limit of the series? I'm just doing the alternating series test. What is the limit of this? Not 1,
Oh, I forgot the name.
but it's going to oscillate between -1 and 1 in the long run. So that means limit actually does not exist, since it oscillates between -1 and 1 like our sine and cosine graph. When it oscillates, we can call it diverges. In the long run, that's what it's going to happen.
so
Because the +2 would not matter, right? In the really long run, when it's in the millions and billions, the +2 is not going to matter. The ratio is what is going to matter. The ratio will come down to not infinity. The ratio will come down to 1, right? Because that's what we figured out. That in the long run, the ratio will be 1. But when we have a -1 to the end, depending on which term we are looking at, it's going to be either 1 or a -1, 1 or a -1, 1 or a -1. So when it's oscillating between two numbers, just like cosine and sine, we call it divergence. When it oscillates or bounded by two numbers, remember bounded, unbounded, when it's bounded by two limits, then it diverges. Okay, tomorrow it's going to be a little hard lesson. Not as easy as it is. We will have to find the interval and radius of convergence. But this kind of gonna help you right there. Like 4 and 5, it's not important for help to learning outcome, but like the type of problems, but I think this will be helpful for you when you do these tomorrow. So if we figure out where it converges, then tomorrow we'll figure out where it converges to. Like the proximity of convergence.
Do we have to?
Yes.
But like, why?
Is there an alternative lesson?
No.
Why not?
Working at McDonald's was the alternative lesson.
I wouldn't mind free fries.
You wouldn't mind working at McDonald's?
Yes, I love that place.
Oh, we know.
I'll make sure everyone's fries are filled to the top and salted perfectly. Fresh out the fryer.
Okay.
Let's see.
Something is missing in the series. What is missing? X. We have to figure out what X could be. But we know that it converges how?
Is that?
It says find the values of X. Read the question. Find the values of X.
Oh.
That make the series converge
Absolutely.
So if it converges absolutely, what do we know about the absolute value?
It's going to be green.
Use a paper towel, Natalie.
What?
You're getting all the peach or apple or whatever fruit that you're eating juice on all of it.
Plum.
Plum?
It's a peach.
Is it peach?
It's already peach season?
No, it's a plum.
Already?
Ask the cafeteria.
And juicy too. Isn't it? Yeah. Okay. Okay, to figure out what the X values could be, we're gonna start with finding the limit of our absolute value stuff. Because the absolute value of that series, we know has to be less than 1 if it has to converge. If you do the ratio test, right? If you do the ratio test for the absolute value,
Yeah.
it has to be less than 1.
Yeah.
So I'm gonna take the limit n x plus 4. Hold on. N plus 1. I should have done that. My bad. And since we're doing the absolute value, I'm gonna ignore this. N plus 1. We're gonna do the ratio test and set it up with less than 1. Why less than 1?
So it can converge.
Because we know it converges. And then we're just gonna solve for x from here, that's it.
Very simple.
Yep. Not hard at all.
I could do this in my sleep.
Congratulations.
Okay, I'm gonna separate all the things that I could separate so I can cancel out quickly. So x plus 4 is going to be x plus 4 to the n times x plus 4 times 6 to the n over 6 to the n times 6 times n times x plus 4 to the n less than 1. This goes away, goes away. Since we are only taking limits on n, I'm gonna get the 6 out of the, actually hold on, let me get all the n's together so we can see how it looks like. So n plus 1 over n, right? X plus 4 over 6. Right? I'm just gathering all the n's together. Good? What would be the limit of this one? 1. This is going to be 1 no matter what. So there is no way that this area is going to be less than 1. If this is not going to be less than 1, then this area must be less than 1. Does it make sense?
It would have to be like a negative.
So x plus 4, no, you're setting it up. So x plus 4 over 6 is less than 1. Absolute value.
When you separate the x plus 4 and the power of x plus 4, would that second x plus 4 be like x plus 3?
No,
Or like x plus...
because it's the n plus 1 is the exponent.
Ooh.
Oh, okay.
Jackie.
Good?
Well, I haven't even finished writing.
Okay. And then remember absolute value equation from inequality from college algebra a long time ago.
Eh?
Wait, what about college algebra?
How do we separate an absolute value inequality?
Oh, would it be like negative and positive or something like that?
Yeah. So that's how you're gonna separate. So x plus 4 over 6 is less than 1.
Can I do it in algebra coin?
X plus 4 over 6 is
what?
greater than negative 1.
Oh yeah, see? In algebra coin? Or not?
And then solve for x. So x plus
Those
4
are not
less
a
than
thing.
6. X plus 4 greater than negative 6. Less than 2. Negative 10.
Can you zoom out?
Yeah.
Thank you.
So what this means is the x value for this series to converge absolutely, the x must be what? Strictly in between negative 10 and 2. This is what we'll be doing tomorrow. To find the interval of convergence and radius of convergence. So, this is a good practice.
I mean, what? Like,
Okay, one more example, and we are done. You can do all the practice in this world.
Or
with the unit.
This down.
Huh?
With the unit. No, you just said we have another lesson tomorrow.
Yeah. I'm doing one lesson at a time, children.
I guess.
This would be a whole, this module would have been done if you went to CCA. You should ask to observe a Calc 2 class at CCA.
No
Go
thanks.
see. Just for fun, C's.
Yeah, sure.
Okay, shall we move on to number 5? Okay. I'm waiting. Huh? Yeah.
Why y'all looking at me like that?
We're concerned.
What do you want?
For real.
Open your eyes.
Are you going today?
Going where?
To the musical?
Maybe tomorrow.
Oh.
Miss, will you buy me the ticket?
Well, what is the difference today and tomorrow?
If I go today, will you buy me the ticket?
What is the difference?
Nothing.
Then why do you want me to buy your ticket?
Well, someone else will buy my ticket tomorrow.
Broke ass.
Why can't they buy this? The same person can buy it
For
today.
Today?
Yeah.
Because they're not going today.
Melissa, what did we talk about? This is not going in a good direction.
That's what I'm telling her.
Then
Oh,
you better-
shut up,
I will buy it for you
Sebastian.
today. Come with me today.
Huh?
Come with me today.
Okay.
You'll, Yeah, can you pay for mine too so I can buy Jackie?
Hello? If I buy tickets for every single person, that's my entire salary, by the way.
See how much money I got.
If you buy it yourself, it's actually cheaper.
I got 34 cents.
It's $6, not for adults.
Yeah, I just got paid. Like $100.
You gotta work more, Jackie. You can't.
I can't. My
Okay.
mom won't let me
Shelby, what? Your mother won't let you what?
work.
Oh,
I can only work 1 day a week.
good.
No, I'm broke.
No, your education is more important.
Yeah, I gotta go straight to work after this.
No one asked you.
I'm just saying.
So if I go today, you buy my ticket.
Maybe.
Ah.
Is Galila not going today?
I don't know.
Ask her to buy your ticket.
Bro, I'll buy your ticket. Damn.
I'm pretty sure your dad will buy your ticket for you.
Am I tripping?
Okay, shall we
No.
move on or no?
Yeah,
Yes.
So for the
Sorry.
one, when the limit of n+1 over 1 turns into 1, that doesn't do anything.
No. It doesn't do anything, meaning that tells us that this has to be less than 1. For this entire thing to be less than 1, if this is already 1, this is just
Okay.
1 times whatever number, right? So this
Dog.
number must be less than 1.
Okay.
You don't smell that?
Smell what? All I can smell is
Whoever
the
smelt it dealt it.
that.
Okay,
and
oh my god. Can you stop acting like middle schoolers, please? Thank you.
it's Sebastian.
What?
Okay, absolute value of the series must be less than 1 because we already know this converges absolutely. So limit this.
You lost me.
Yeah, so you just wrote all that down like instantly.
I'm just replacing n with n+1 and just doing the ratio test. Cancels out, cancels out.
Ooh.
This n is being multiplied, not with the exponent, so everything else is. So limit n approaches infinity. I'm gonna gather all my n's together so I can clearly see what's happening. Times x minus 1. Right, that's what is left after we simplify things.
Yeah, I got that same answer.
Okay, and we know this limit is going to be
1.
1. And so this has to be less than 1 then.
So it's gonna be x minus 1.
So -1 less than x minus 1 less than 1. Add 1. So 0 less than x less than 2.
Bless you.
Bless you.
Bless you.
Bless you. Galila is here. You can ask her. Well, she just arrived. She's walking. But you can ask.
Okay, so these are the values of x between 0, strictly between 0 and 2, where the entire series will
Bless you.
converge absolutely. That's what it means.
Thank you.
Is that the whole lesson?